This is the Temporal office hours. We're trying to do this once a month, kind of the last Tuesday of every month, I think, something like that, or second last. I'm not sure. I'm Sean. I work on developer experience at Temporal, and we have a bunch of really good speakers today. And yeah, I'm just gonna kick things off because I'm not sure. But and by the way, feel free to introduce yourselves, and also bring some questions, talking about where you are with your temporal journey, where you work, which city you're currently at. I'm sitting down here in Federal Way, which is kind of south of Seattle, and it's just the start of the day for me. Okay, so let's keep things going because we have a pretty tight schedule today. So we have a bunch of links for people. I think if you're familiar with Temporal, these are the ways in which you can get support, or follow along on Temporal news. We also have a bunch of published case studies. We have a couple more coming out recently, actually. But so far, people who use Temporal really like blue logos. That's something that I've noticed because apparently blue represents safety, and people who value reliability and safety tend to pick blue and to pick Temporal. All right, so the agenda for today, we're gonna go straight into some demos that Tiho has put up. Tiho is our wonderful developer advocate, and then we're gonna go into our first customer presentation. I think it's gonna be a sort of interview style Q&A thing that we've prepared with Shannon. And then finally, Dominik's gonna present on the Temporal event loop that really is core to how Temporal keeps, I don't know, I think it's how the brain of Temporal is you don't have, every framework at its core has an event loop. And then we'll leave some room for Q&A, so definitely post your questions in here in the chat and we'll answer them. We have all the founders and and the core team of Temporal here to answer your questions. All right, Tiho, you wanna share your screen, or do you want me to go to your slides?
I'll go ahead and share if that's okay.
All right, let me pop up. All right, here we go.
All right. I'll continue with the slides that you have. We kind of have the same one. First, hello, everybody. Thank you for joining. I'm Theo, I'm developer advocate here. And I will very shortly talk about some Polyglot and show some demos around the Polyglot part of Temporal. Now I'm very interested in the kind of multi-language aspect to Temporal and how you can write different apps in different programming languages and have them communicate with each other. So what I've done so far is we've created a number of examples. And the first one, I just wanted to list them real quick in case you weren't aware of them. But the first one, this is kind of like the Temporal Polyglot, and here's the GitHub URL. And that's a small example that uses all four of the Temporal SDKs, so Java, Go, PHP, as well as Node.js. And it's just a small demo that shows kind of signal handling and sending signals and stuff like that between different workflows or microservices written in different programming languages using the different Temporal APIs. The second thing that we then also produced is a little bit of a Temporal snake game, which we also showed or demoed in one of our recent YouTube videos. And if you haven't seen that yet, go check it out on our YouTube channel. It's called Polyglot Microservice Orchestration. And at the end of the video, we show the demo, which is kind of like a really cool snake game that you can move with your keyboard. And it uses, I think, a PHP, Go, and the Java SDK for the controls of the movements of that game. The one I wanted to really shortly show today is it's a pendulum game. And I wanted to just go ahead and show it off real quick. What this game is about is it's a pendulum, and we have three different workflows: Java, PHP, and Go, which all know how to control the movements as well as store the state of the pendulum as it's moving left to right. And so I'm just going to go ahead and start a demo, and then we can take a look at it. It's very simple, and then we can talk about it a little bit. So what happens is just a Java client. It's a game that shows a pendulum moving from left to right. It has acceleration, it has an angle, in different positions. And this particular workflow game, when we started, we can see here that we started 3 workflows. One is our Java, PHP, and Go. Right now, the buttons control really which workflow is currently going to be responsible for the positioning of this pendulum, right? So what you can do is, in this game, seemingly switch from currently Java, which is the blue one, and we can see that because the Java one is currently getting all kinds of history events, whereas the Go and the PHP have only started workflow execution. But let's say when we switch to PHP, what happens is the game knows how to switch from one workflow to the other. It passes from the current workflow that maintain the state to the PHP one, and the PHP one then continues calculating the movements, the angles, the acceleration of the pendulum, and storing that state as well. And as we can see now, the PHP workflow started getting all kinds of signals and events to control the movement. And we can also switch it to Go. So the position doesn't change. The state of the pendulum is passed from workflow to the next. And you can switch basically from one workflow in different language to another using these 3 particular buttons. And I'm planning to add Node.js in the mix as well. So anyways, when we stop the game, what we see here is the signals get sent to all of the different workflows, an exit signal. And if we see all 3 of them have completed execution. Now, if I wanted to show a couple of things, if you're interested in example, we showed the URL, but a couple of things that it shows. Number one thing I wanted to show is that the management of data. So basically data being passed in JSON format from one language to the next, and Temporal takes care of the marshaling and unmarshaling for you. So just to show you is, we have a game info object. This is a Java, just a POJO, which maintains the positioning of the ball, of the angle, acceleration, all kinds of stuff. Whenever that is passed to the PHP workflow, we also have a game info class here written in PHP that just has the same fields. For the Go, we have a struct here that has the same fields in that. So what I wanted to show is, as far as passing data and the conversion of data from the JSON format to the different programming languages, that is all done for you. So we can just basically do that. And another thing I wanted to show why this kind of example is interesting is that we can use a same interface to access all 3 of the different workflows written in different languages. So in Java, we have our workflow implementation, and this is our workflow interface. It defines the workflow method, a bunch of signal methods, and a single query method, which is used then to pass the game information from one workflow to the next whenever we press the button. This interface is in Java. The client can have the same interface. Of course, this is also in Java. So client is in Java, so they can communicate like that. In Go, we don't have interfaces, of course, but what you can do is you can still use the Java interface, so the workflow method or the workflow name, which is the positioning workflow. So in Go, we can create a function called positioning workflow. And then for the signal methods, we just have to match the signal names for each one of our the channels that we pass to our selector. So if they match, that will be fine. And for PHP, this will actually, it's fairly easy because PHP is very similar to Java. It still has an interface. So as long as the workflow and signal methods match, you will be able to use a type approach from your client, Java client, to call all of these workflows. And that's just to show that real quick. I wanted to show in the game, we have workflow utils. So you see we have here 3 workflow stubs. One is the Java workflow stub that calls the Java workflow implementation of the pendulum. The second one is the PHP stub, and the third one is Go stub. And all of them use the Java interface called positioning workflow. So we don't have to use untyped stubs. We don't have to use the string representation of each of the workflow types. to invoke this particular workflow, we have a typed approach to actually control different workflows in different programming languages. So again, going back to the slides, yeah, this is the URL for this particular demo I just showed. And if you have any questions, let me know, or yeah, just feel free to contribute to this demo as well to make it better. Thanks. That's all I had, Sean.
Okay, that was awesome. For those who don't know the behind the scenes, Tiho actually had a different demo prepared. I mean, he was going to prepare the snake demo, and then he just like whipped one up overnight, and it was super impressive. I think the visual capability really sells the idea that you can transfer things back and forth, and it's kind of language agnostic, which is pretty cool. Okay, so the next piece that we're going to have is kind of a conversation with Shannon. Hey, Shannon, you there?
Hi, can you hear me?
Yes, Shannon, I can.
Yes.
Are we going to do this? We don't have slides, right? We just are going through a prepared points.
Yeah. I think so.
Okay. Let me see how I can pull this up. Give me 1 second. Let's see, because like essentially what we decided on was that would be a lot smoother if it was just more conversational rather than coordinated like this. Okay, just give me 1 second. Okay, so you know what? I think we'll just do. Let me just pull up the talking points. Let's see, Shannon. All right. Okay, so yeah, we're just gonna do it like a chat form. So hey, so Shannon, you want to introduce yourself and where you work?
Yeah. I mean, just as a heads up, I think one of the reasons why we had to switch to this was Sean and I and Rylan were having dinner last night, and I was realizing that I might not have time to make some slides, and so we decided to switch it to a Q&A format.
So it's our fault. It's our fault. Temporal's fault.
It's not your. I mean, it was enjoyable dinner, so I am thankful for that. But yeah, I wanted to quickly whip something up, and slides seemed a bit more difficult. So in any case, who am I? I'm a software engineer and one of the team leads on the platforms team here at Bolt. And I'll go more into Bolt in a little bit. I've been at Bolt for the last couple of years, and so worked on a variety of different things throughout Bolt, but more recently on the platforms team. We're working on sort of all the horizontal efforts that help improve our speed of delivery and reliability, which is, I think, one of the reasons why we are looking at Temporal.
Gotcha. I want to ask you more about Bolt later, but one of the questions actually that I always wondered is, when do people have platforms team? This is essentially like an internal developer productivity team, right? A team to serve other teams.
Yeah. A hard question to answer. I don't know if I would be very authoritative on it. I think at Bolt specifically, we had a need where everyone was sort of focused on products, but no one was quite working on some of the horizontal efforts. And so a lot of us were doing it kind of in our spare time. And then after a while, it became enough that we transitioned into a platforms team sort of organically. And it's been kind of growing from there.
Okay, awesome. We should probably talk about what Bolt does.
Yeah. I guess the first thing I must admit is that there are multiple Bolts, I think, across many different continents. And I actually think I learned of a new Bolt that is in Canada today that is different than the Bolts that we are based in the US. So Bolt here in the US, we're a checkout platform. So we're focused on building a seamless buying experience across many merchants and platforms, and that's related to our adoption of Temporal. So our goal is to like democratize e-commerce by hoping to build a shopper identity that can be utilized across merchants and platforms. I think right now what you'll see is a lot of the shopper identities are either isolated to a specific merchant or to a specific shopping cart platform. What we're hoping is by working across these different shopping cart platforms, as well as these different payment processors, we can allow merchants to take advantage of a shopper identity that would have been pretty difficult for them to build out otherwise. So yeah, I guess that's the pitch of Bolt.
I guess we should also, I mean, I should also just have this on screen while you talk about bolts.
I don't know if there's going to be a lot of overlap here between us and Forever 21 shoppers, but Forever 21 is one of our major merchants, and we're also launching a few more in the coming weeks and months. And so hopefully more and more of you will be exposed to the Bolt brand going forward.
I think we need whoever works on your website to help us with ours, because this is pretty cool. I love the morphing SVG thingies. I assume it's SVG. I'm not sure, but this is cool. All right. So how do you come across Temporal, and how do you? It's an interesting use case.
Yeah. I think there's a few different steps. Like, admittedly, like we first came across Temporal because I had a teammate who was working on data engineering and building out our data platform, and they were using step functions. They had actually come across Cadence in a Hacker News thread, and so they had linked me to it because I was sort of doing an evaluation between investing more time into our existing asynchronous work framework, which was based on Golang's machinery, or any sort of tool that was out there, whether that was open source or managed. And so, yeah, we managed to come across one of these Hacker News posts, and actually at the time it also happened to align exactly with Maxime and Samar really getting Temporal going, and so it was a great fit already from the start. I think Sean had a question for me when I originally sent him over this question. Is like, why did we sort of think about investing in our async work framework? And I do think that that's like a pretty common thing, is especially as a platforms team, you try to build out these tools, and one of these tools is really this asynchronous work framework. And for the most part, our framework was okay. It did the job, but what we would have to do in many cases is, create some task table within our database in order to transactionally store some work to be executed. But then when we wanted to handle a new object, it would always require a new database table, a new code, more code to be written. We wanted something that was like a little more flexible and also let us sequence steps one after the other. That's definitely one of the reasons why we came across step functions, but I think Temporal was definitely even more flexible in how we can support that. And that's definitely one of the big reason why we're using Temporal. I guess the other things that really stood out were the Go SDK, because we write everything in Go at Bolt, and so the Go SDK was a huge part of it. And then the testability and readability of workflows was another big selling point for us.
What is your user journey when you evaluate tools like Temporal? Like, you come to the landing page, it's like, okay, marketing fluff, right? And then where do you go next?
I think that was definitely at the time there wasn't a Temporal website at the time, so I was actually just scouring the internet for
GitHub
content. So I looked at the GitHub. I also looked at a lot of Maxime's and Samar's talks from the past on YouTube, and started trying to really grasp my head around this technology. Before I even wanted to pitch it internally, I really wanted to just understand, how does it work? Because it sounded a bit too much like magic to start, honestly. And I wanted to really understand, like, from a first principles perspective, like, how does it work? How does it give you these paradigms? So it was really, really it took me a lengthy process of researching and reading in order to really understand. But fortunately, all of this content is now really well posted, and I would highly recommend consuming this content to really understand how Temporal is able to provide, I think, what looks like magic.
Yeah. Thanks. I mean, I think we have a lot more work to do to surface this stuff to you. And we do have a YouTube now that we try to update and groom. So if you just check out our YouTube, I think that we have like various channels that we highlight. So like a getting started, an SDK tutorial, office hours recording, stuff like that. We're just trying to surface the stuff you want faster, I guess. Okay, so you've evaluated Temporal. You think it's interesting for your async workflow platform thing. How do you pitch it internally?
Yeah. So I think even though we were looking for something that was like sort of an improvement across our asynchronous work framework, this was going to be a heavy lift, right? At the time, but prior to Temporal Cloud, it was going to require a lot of investment on our end in order to spin up a cluster, in order to do all these things, and also it's a big shift from writing step functions or investing in more time in our existing framework, and so. People say to not look for problems with a solution in mind, but I felt like I came across this really magical solution that I really started to understand and see the power of. And so honestly, I was in search of problems to solve. At the time, and to some degree still, Boltz was fairly monolithic in architecture. And so the whole typical story of microservices and orchestration wasn't necessarily something that immediately stood out as a benefit. Certainly over time, we're trying to build out those in a very gradual format. And I think that's probably the right journey for most microservices. But, before you get there, how do we get this started, right? And I think I started realizing something pretty critical. So Bolt does, as a result of the nature of our business, we interact with a lot of different systems, merchants, platforms, payment processors, alternative payment methods like Apple Pay, et cetera. And so by virtue of that fact, we have a distributed system, and even worse yet, one we don't really control. And so this was one big selling point for us, is like, as we start to build out these integrations with other products, which is one of our big value propositions, obviously we have to do it sensibly and we have to make sure that it works. And so Temporal was definitely a way, while we can't necessarily run Temporal on a shopping cart platform, we are able to write, clients on our own that would be sort of representative or make those RPC calls to these platforms. And so this was the big selling point for us internally. And then I would say a lot of people were excited about the fact that it was in code and that we could write unit tests. So that was a big thing. And fortunately, the engineer who was using step functions was running into a lot of troubles with JSON and DSLs. And so it was like the perfect confluence of factors that made Temporal like a good bet for us.
It sounds like you didn't have to sell it very hard then, because you're already
I,
feeling for the people.
I'd like to give myself credit for trying to sell it pretty hard. I'm not going to lie.
Awesome. Okay, so and then you went through tech evaluation, and more people, if anyone has questions about that, feel free to throw it in the chat. What's your thought process about adopting it once you've decided on adopting it?
Yeah, so I think as folks on the Temporal side know, it's been a long journey. So I started talking to Maxime and Samar, way like last February or March, and Rylan, basically the day he joined, and Sean from as well. And so it's been a long time. We've been slowly rolling it out, to be perfectly frank. Bolt has been growing incredibly quickly in the last, particularly in the last year. And so we've had to manage it amongst many other priorities, sort of the existing system and trying to scale the existing system while trying to also prepare what the future state of the system looks like, and Temporal being a part of that. So, and then also just making sure that we have the internal knowledge and capability to support it means that we have to try to like slowly ramp up the knowledge and make sure that folks have the right use cases that are good fits for getting that exposure, not necessarily good fits for Temporal, but really good fits for getting exposure to a lot of different parts of Temporal. And then that way we can sort of slowly build that wheel of knowledge, and then they can carry it on to helping others within the company whirl out into Temporal. So we did have to start with one use case, and so we're in the process of rolling out, or we've rolled out one use case, and we're in the process of rolling out another use case. The first one we rolled out was within our fraud data pipeline. Actually, I'm gonna share a quick sort of diagram. Yeah, I did manage to have these resources up. So part of what we had before was, we have one of the things that we do as well is we do fraud indemnification for our merchants. And so we do have to obviously gather the data to make the decisions on a transaction. So we did this asynchronously. If you look at it from a high level perspective, we have a task again in our sort of async work framework. We have to generate a bunch of data, and I guess not necessarily generate, but collect a bunch of data and then eventually make a risk decision. So this was sort of our pipeline originally, where we would generate each of these sources sort of in order, merge all the inputs, and then save to a store. So DynamoDB or Postgres, et cetera. And so one of the challenges that you have with this is, what if it fails on source? And what we ended up having to do is rerun this whole pipeline in order to generate the data again in order, by virtue of, like, these literally being function calls after the other. And so this was costly and inefficient. Costly in the sense that some of these data vendors are, do cost money. And so getting that data, and having to ping data vendors again for duplicate data on the same transaction was costly or inefficient. And so with Temporal, what we were able to do is basically generate these all in parallel, and then also each of these having their own retry policies allow us to retry for specific data vendors, and then coalesce all that data into sort of the same step, and then saving that back to the store. Let me see. Actually, the other use case that we're kind of rolling out, I'm having trouble zooming in on this. Oh, there we go. Here we go. Is something that I'm less proud of showing at the moment, but you can kind of tell this is the current, this is the sort of the current state, and this is where we would like Temporal to look like. And so while I understand that, like, Temporal is not a GUI based solution, I think it was really helpful for me to diagram out what it would kind of look like in a flow, and then carry that over into code, and then obviously be able to test that code. So yeah, those are the sort of two use cases. The first use case that we've successfully rolled out. The second use case that we're in the process of rolling out, again, as also a way for folks within the company to get exposure to the technology. And then in the coming quarters, we'll really try to start expanding that pretty quickly.
Awesome. For what it's worth, the second use case wasn't very clear. Like we just saw some diagrams. But...
I'm not still working on it, and so I'm not proud of diagramming it at this time. I didn't put as much polish as you or Rylan would expect, so that's why I was holding off there.
Hey, I mean, I think people like to see work in progress, and that's a lot of. It's just realistic. That's what a lot of our work is like. But yeah, it sounds like the benefits was that you were able to parallelize, and also probably some cost savings, but primarily because the original system was so inefficient that it just retried the whole thing. And it's pretty. I reflect that, like, it's pretty similar to video encoding actually. Like we have one of our case studies, the script. They basically, break up an audio file and transcript in chunks. Pretty similar. Yeah. Awesome. Okay. So, and then, what part of this was, prototyping in like a local Docker situation, and then deciding to go with Temporal Cloud versus self-hosted?
Yeah, I think, Bolt at Bolt, we've been primarily focused on speed of delivery in comparison to anything else. And obviously reliability being another huge part of it. We felt like if we could get a hosted solution that would really improve the adoption path for us, I think, really finding the resources to support the persistence as well as the cluster itself would take a lot of work. And so we're really thankful, as well as had been asking for a very long time to get onto Temporal Cloud. And so we were fortunate to be one of the beta customers, which has had its own fair share of hiccups, but I'm really glad to have had the Temporal team as a partner through all of those hiccups. But it's dramatically been, I don't think we would have been at the Temporal adoption that we are here at today without it. I think it would be quite a challenge for us internally to have the resources dedicated to such a project.
Gotcha. I think Rupak has been talking about it in I think one of the podcasts he did on software engineering radio or something. Okay, so yeah, any I mean, so okay, you know, really happy that you're on Temporal Cloud. Obviously, thanks so much for taking the time to do this little presentation. Wasn't too bad, right?
It wasn't too bad. I appreciate you as an interviewer, Sean. Ryland, if it was Ryland interviewing me, I'm not sure I've done so well.
I think you'll get along fine.
I would have grilled you, Shannon.
Yeah, so I guess you know, we're basically done with our prepared questions, and obviously people can follow up with you in the chat if they have any other follow-up questions, especially if they have, you know, e-commerce situations or data pipeline situations. I think Shannon has production experience with Temporal.
Yeah.
Any other advice that you have for just generally people checking out this technology, and you know, just what would you say to yourself starting this journey?
I think what's really cool for me personally, as I look back on Temporal, as look back on my own personal journey with Temporal, is like really taking the time to, I think, again, understand how the magic is, you know, how the magic is done. And I think what's really cool is that it's obviously incredible amount of work over the years from Maxime and Samar and others to get it to a current state, but it's also not magical. And I think that's like something that for whatever reason is really intriguing to me as a software engineer, and knowing that this is a system that's built like based on pretty core concepts and really good engineering. And then also just taking the time to understand the technology. And I just have to give massive thank yous and shout outs to Maxime and Samar, who fielded a lot of my questions at the beginning, Ryland since then, and then all the other folks from there. Really just massive thank yous. And this is the least I could do for all the help I've gotten over the past year.
Awesome. That was a wonderful presentation. Thanks so much, Shannon. And yeah, if anyone has follow-ups, you know where to find him. Awesome. Okay, cool. Yeah, speaking about the magic of Temporal and how I think we are working very hard to dispel or to explain the underlying magic behind the scenes. And one of our best explainers is Dominik. Dominik, are you there?
Yep.
All right. So we're going to have a presentation on Temporal's event loop. Why don't you share your screen and take it away?
Awesome. Thank you very much. Yeah, I love the sentiment of Shannon. It does feel like magic, but it is actually rooted on rock solid engineering. So today we pull away the curtain a little bit and have a look at that engineering. And we will mostly look at the how this is all done. But just as a quick reminder, what Temporal is all about, I would say that the core property, the main property of Temporal, is all about reliability, and also arguably the main selling point of Temporal is its reliability. And if you think about workflow functions, Temporal gives you one guarantee, and that guarantee is that in effect, a workflow function is going to be executed exactly once to completion. Now, that sounds actually fairly mundane, trivial, innocent. But on the other side, if you think about it, if by virtue of eliminating possible failures and partial failures, every distributed problem actually becomes trivial. Now, let's look into how Temporal actually does that. All right, quick sanity check. Can we see the screen?
Yes, sir.
Yep.
All right, thank you. All right, let's look at how Temporal works based on an example. And the example is a straightforward money transfer workflow. So the transfer workflow is going to take from account to account in an amount, and then it's going to transfer the money from the from account to the to account. And as a result, we will get a confirmation number for the from account and the confirmation number for the to account. And internally, we use one activity twice, update activity. To update the from account, we're going to subtract the money, and then update the to account, we're going to add the money to it. So in let's say Golang like pseudocode, even so that Golang doesn't have an await. This is again pseudocode, should be transferable to Go, PHP, Java. So we have the transfer function. We execute the activity update once to subtract the amount and once to add the amount, and then we return the confirmation numbers. So you see await execute activity. So we actually, this is a very nice interface, but for our discussion, we need to de-sugar that a little bit. So there are two things going on. First is we're going to queue the activity or execute the activity, start the activity, name update on the queue update, and then we await the result. And that we do that twice. So we will look at the mechanics basically on the de-sugared level, but usually you're going to see something like await execute activity. All right, how does this all work? Okay, so we have the temporal server in the middle coordinating between two workers. Here we have the workflow function transfer on the left and the activity function update on the right. We will mostly focus on the workflow function, kind of speed through the activity function. So here we're going to start our workflow with the start workflow execution call, and we transfer from the account 123 to the account 234 $50. All right. Temporal is going to record that as an event, as a workflow execution started event with all the arguments. Now, as soon as this event is recorded, Temporal is going to guarantee you that in effect, the workflow function transfer is going to run exactly once to completion. How is that done? So the first thing Temporal does is it schedules a workflow task, and the workflow task has all the arguments: transfer 123, 234, $50. So let's look into the first workflow task execution. So Temporal invokes the workflow function and therefore sets the local environment of the function to the values. You can see the values at the current values of the local variables at the bottom. And also on the right side, we're going to track a list of commands and a list of history. We will look into that shortly. So we jump into that await execute activity. Again, we need to look at the de-sugared level. So we look at queue activity. When Temporal executes the command queue activity, we write the command update 123 minus 50 in the command list. Nothing else happens. We are basically just recording the intent that we want this activity to be executed. Now, the interesting part here is await. As soon as we await, we are basically awaiting on a result. And here, Temporal sees that there is no entry in the history table that corresponds to this update 123 minus 50. So it has not happened yet. What Temporal does now is it will take control from the workflow function and yield back to the server with a respond workflow task completed API call. And within this API call, we embed that we want to schedule the activity task update 123 minus $50. That will be recorded as an event, workflow task completed, schedule activity update 123 minus 50. So that triggers Temporal to actually execute that activity task now. And again, we're going to speed through that a little bit today. So the activity function will then transfer or will update the records and subtract $50 from the account 123, and then respond with an API call, respond activity task completed. And here we get the confirmation number 9A8. Again, Temporal records that as an event, activity task completed 9A8. So the next thing that we're going to do is we start another workflow task, or we create another workflow task, the workflow function, to make progress. This time, however, we have something in our history. Update 123 minus 50 already has happened. So let's look at the second workflow task execution. The most interesting part here to realize is that Temporal, if we take any optimization out of the equation, that Temporal restarts a function from the very beginning. We just restarted. So the same as before is going to happen. So we're going to queue the activity update from account 123 minus $50. We queue that, and now we once again hit an await. But the difference here is that now we have a corresponding entry in the history table. So instead of yielding back to the server, we see, all right, this has already happened. So let's just take 9A8 as a confirmation number, put it into the, assign it to the local variable and move on. Cool. Now we are at the second activity. Same principle. Let's just queue, or Temporal will just queue, will record the intent that we want to call the update activity now from the to account and from the to account 234 with plus $50. That is all we're going to do. We put that into our command list. Now, when we hit the await, this is when we again need to make the decision, has this already happened or not? Well, in our case, this has not happened yet because there is no corresponding entry in the history. Therefore, once again, we're going to take control from the workflow function. We kill it. We take it from the workflow function and transfer control back to the server. Once again, we call the API respond workflow task completed. Now we say, please schedule the activity task update from 234 plus $50. We record that as an event. And because we record that as an event, an activity task is going to be created. Activity task update account 234 plus $50. And again, after the records are updated, we respond with an API call, respond activity task completed. And now we're going to get the confirmation number D45. We record that as an event. And once again, we need to make progress on the workflow function. Therefore, we create another workflow task. However, now we have two entries in the history, update 123 minus 50, update 234 plus 50. Okay, third and last workflow task execution. So once again, we start this thing from the very beginning, right? There is actually absolutely no magic involved here. We start this from the very beginning. We hit our queue activity command. We have that command. We record that intention. Nothing else is going to happen. We hit the first await. Well, we see that actually this has already happened. There is a corresponding. Therefore, once again, use return value of the first activity as the result for this await. Now, second time, execute activity. We queue the activity update from account. Oopsie, sorry, that is a copy and paste failure. It's always at the presentation when I realize these things. So then we take this, put this, record this in the command history, update 234 plus $50. The await. This time, the second activity also has a corresponding entry in the history. So this has already happened. So we can just use the return value for it, which brings us to our very last statement, where we return both the from confirmation number and the to confirmation number, 9A8 and D45. We record that as a respond workflow task completed, complete workflow execution API call. Therefore, we record that as an event workflow task completed with the complete workflow execution 9A8D45, which then triggers Temporal to actually record the event that the workflow execution itself has completed with the event 9A8. I'm sorry, with the argument return value 9A8D45, and which then is going to be the return value for our initial call to the transfer workflow. Therefore, we concluded the execution transfer from account 123 to account 234, $50, which will yield the confirmation numbers 9A8 and D45. So if we have some time for a quick recap, we can look at it in a different graphical representation. So the workflow execution itself, right, is made up of activity executions, and it is on a technical level, it is a back and forth between workflow task executions and activity task executions. And if you look into the three workflow task executions that we saw, first we were recording the command update, our first command, and we're deciding, has this already happened? It has not happened, therefore it materializes, and this happens in the context of the workflow execution. Now, the second time around, we see, has the update, has the first command. We record that command. We then make the decision, has this already happened? And it has happened. Therefore, it's not going to happen again. We deduplicate it and now record the intent to execute the second command. Has that already happened? It has not happened yet. Therefore, this command materializes. And therefore, in the workflow, for the workflow execution overall, we now have the two commands, update account 123 minus $50 and update account 234 plus $50 in effect exactly once and to completion. All right, and that actually ran this presentation exactly once and to completion. Thank you very much, Sean. I'm going to hand this back to you.
That was awesome. Actually, I always wondered if we basically, like, does any part of that story change if we have timers? If we
actually, no part of this story. Of course, there are other events involved, right? So there is other events, and we are then not waiting on an activity. We are waiting on timers. But the story itself does not change. And interestingly, if you think about it, also in the presence of any failures, of any crash faults, for example, if your worker crashes, or if there are temporary outages in the network, the story doesn't change. The most fascinating part to me is that temporal does not make any difference between an execution that runs smoothly and an execution that is interrupted n times by faults, crash faults or network faults. From temporal's point of view, there is absolutely no difference. Yeah. So when Max says that temporal workflows are fault oblivious, he does have a point. A fault is not even a top level concept. It is the normal execution model to just start from the very beginning and deduplicate everything that has happened so far.
Yeah, something I like. So it's basically, you take the execution, you chunk everything up, you persist at every stage, so you can resume at every stage. Something I like that you get for free out of this is horizontal scalability, because you don't really care where it executes.
Yes, absolutely. You do not care where it executes, and if in doubt, you do not care when it executes. As soon as, for example, you bring your workers back up, or as soon as the network partition is fixed, temporal will make progress again, guaranteed.
Gotcha. So if anyone has questions about how temporal works, feel free to throw it in the chat. I'm going to ask one more question, and then I want to highlight something that Dan Davison asked in the chat. So Dominik, one more question, which is basically, I just forgot my question. with like, I'm trying to moderate plus ask questions. Okay, I'll just feature Dan's question. Basically, he's saying, can either of the following be done without too much pain from languages without SDKs? A, send activity task completed, and B, initiate workflow instance. And Max says, yes, Temporal SDK uses gRPC to communicate to the service. So any language that supports gRPC should be able to call respond activity class completed and start workflow execution gRPC methods. It's just something I actually didn't really understand, like why it was so important for Temporal when it's forked off from Cadence that it changed protocol to gRPC. If you're using our SDKs, you don't really care about the protocol, but some people care. Like, why do people care about gRPC? Or it's just a curiosity of mine.
It is, so it's like, if you want to write a temporal workflow function, yes, in theory, you can do that without our SDK, but you probably do not want to.
Yeah.
If you want to start a workflow execution, or if you want to signal that the activity task completed, you do really have the option, right? So if you want to talk the gRPC protocol directly, that is a valid option that you have. So still, of course, the SDK makes it more convenient, but it is not a horrible experience if you want to bypass the SDK in that case. And gRPC makes calling APIs from different technologies fairly straightforward. So I think this is why a lot of people are into it.
Yeah, for those who don't know, we actually keep all our protobuf definitions in temporal.io/API. Yeah, you can just check it out all here. And I mean, it is open source, which is beautiful.
I think one point is that both TCTL, like our command line interface, and UI actually use this interface. So there are no backdoors. There are some admin commands which go directly to the database, but most practically the whole UI and command line just go for this. You can write your own, for example, just using this gRPC interface.
Is this where people would start if they were interested in writing SDKs as well?
I know, I wouldn't recommend that. It's just too complicated. We have SDK core written, which we are writing right now in Rust. And the idea would be that all new SDKs should use SDK core, because that would save 90% of effort to write a new SDK.
Yeah, for those interested in following along on our Rust core SDK, it's basically an SDK, which is what I like to call it, because it's an SDK to make other SDKs. It's also open source, and it's coming along nicely.
Shannon had another question. He said, I'm still curious around how we interrupt execution on the Go SDK when we hit the next missing history event, or do we run the method to completion and just record the next history event? I'd love to peek under the hood there.
I can give a very short version of that. Practically, when we need to interrupt, because it's thread, right? We are blocked on that routine. The most important part is that it should block on the temporal API. And that's why you have to use these silly wrappers around channel and selector and whatever, because unless we hack the actual Go runtime, which we might do one day, but right now we practically give it as a library. So we use cooperative multi-threading because we have to guarantee determinism. And when it blocks on our API, what happens is that when you need to practically release that Go routine, that API internally will just call, I think there is this exit Go routine, there is some API and to kind of exit the Go routine. And because it comes from our API. In Java, it just throws an error. There is like a release, I don't remember, like a release thread error or something like that. And big assumption that you don't catch throwables in your workflow code in Java. So only if you want to catch everything, catch exception. And this error just propagates up to stack, and we can release the thread. No magic.
Cool. Another question from Matthew Moore. Matthew, actually, you're welcome to come on the screen and ask questions. We don't have to do this all in chat.
Sure. Yeah. I mean, I was just, I've been observing Rust gathering momentum in the distributed system space. And I see that Temporal is using Rust now at that SDK level. And I'm just curious if you, kind of like Linkerd did, have plans to implement Temporal server itself in Rust at some point.
I think right now, Temporal can always saturate the database. So practically, it's always IO bound on the database. And rewriting the Temporal itself in Rust will save on some resources, but reality is that it's not something which will completely change the way the software behaves. So if we ever start putting more effort in the optimization, we probably would optimize the database layer or how we access, store data instead of just changing the server. But maybe one day, right? We don't know what will happen is we might rewrite some components. I can see clearly, for example, something like front end being rewritten or matching engine being rewritten in Rust and being much more efficient.
I would say generally we become bigger and bigger fans of Rust at Temporal. I think we really see the value it provides as a language because it provides a lot of value that's sort of relatable to the value that Temporal provides. I think actually a more interesting question, Max, is if you had to write Temporal today, would you use Rust?
I certainly it would be a strong contender. At Uber, it wasn't a possibility back then just because Uber had kind of blessed languages when Cadence was written, and only Java and Go were blessed languages back then. And I still think Go is okay. I understand that Go is not Rust, and Go a lot of people have don't like that too much. But I think as a practical language, it's a very good language. You can get a new engineer who never learned Go, and in a few weeks he can write production-worthy code in Go. In Rust, it certainly takes half a year until you can master it on some intermediate level. So yes, I like Rust, and I wrote some code in it. But I think like unless you have like very strong team which actually already knows Rust, you should be very careful. But yes, I think long term we will have more and more Rust.
Awesome. I see another question. I can take this one. What's the status of the managed service? I made a request yesterday for consideration, but haven't heard back. Should I expect a delay? Did I submit the wrong email address while we wait to figure out managed services?
Oh, no.
There's more of the question. Which temporal DB should we upscale for our initial load testing? So the first part of the question is, I actually don't know just off the top of my head whether we received your email. I would say that it's fairly likely that we did. We don't, immediately reply back to those things. In all honesty, the throughput in the ingress is very, very high at this point, and so it's kind of not even feasible for us to respond directly to every single person. That being said, we do look at all of them. We triage them, and we kind of prioritize them based on whether they're going to be a good fit at our stage and at the stage of the company that wants to use the cloud. Sean says that we did. So yeah, we've definitely seen it, and we'll definitely be reaching out to people as we kind of make our progress through that backlog of users and customers who want to get on the wait list. So it's definitely there, and we appreciate it. In regards to the second part of the question, it's actually quite difficult to answer without understanding exactly what your use case is and what amount of scale you're running Temporal with. Generally speaking, for like just getting started and playing around, the Docker setup is more than enough. But once you get to the point where you actually need to run with a production offering or production system, you definitely want to be using like a minimum hosted version of MySQL or Postgres, and then setting up something in like EKS or whatever compute scaling solution you want to use. And so yeah, and then obviously there's a point where if you have enough scale, you'll definitely need to move to Cassandra if it's really at a high enough throughput. But we almost always recommend to people to start out trying to figure out if you can make MySQL work. If it's clear that it's not possible, you're going to scale out of it very quickly, then you need to start looking at Cassandra. Awesome.
Thank you.
People are welcome to come on screen and ask as well, because otherwise it's just us reading chats, and it's kind of like a weird experience. There's one. Any updates on DSL examples for Java SDK? Ooh, I think this is maybe a Tiho question. Do we promise DSL examples for Java SDK?
Yeah, we actually, we're working on it. We do have a sample for the Go SDK, and I'm working on that right now, and we'll have it looked at and make sure it's all good before, and then we'll push it to our samples Java GitHub repository. I think it should be within a week or two. I think that's how kind of like a time frame to throw it out there.
Right. And
the question.
Yeah, totally. And I think we don't have any particular opinion on what DSLs you should develop on top of Temporal. And it's really up to you in terms of your programming and your system design. But obviously, I think we can help people a lot if we just give some starter examples. I think the Go one was very helpful for me to understand how to interpret things and translate it to Temporal. Cool. Do we have? Oh, okay, great. All right. So, do we answer Amit's question? Amit, do we answer your question?
No, we about the deduplication.
Yeah.
Yeah, I think the question is, can Temporal be used to duplicate requests? Yes, absolutely, because Temporal guarantees uniqueness of workflows by ID. So there is hard guarantee. First, Temporal is fully consistent service. So like it eliminates a lot of race conditions, which you would have if you built a service on top of database and queue, just because you don't have transactions between them, unless you do a box pattern and other things. So you can absolutely have a workflow which will make HTTP request and store the result in the workflow variables. And then when it gets the next request, it can check those variables and perform whatever logic is necessary. But again, it kind of assumes that there is a workflow instance with a specific ID running and making that request. And it's we probably want to look into the use case more closely to understand what exactly you're trying to do.
Hey, Max, I would like to highlight, if I'm understanding that sentence correctly, means having data of previous requests saved temporarily to filter the new data. So with Temporal, you actually do not need to persist that anywhere. You can just keep it in a local variable, for example, a list or an array, throw it into the array. Temporal will make sure that array is going to be kept around. So saved temporarily for you basically just means saved in a local variable. So it's very straightforward, very easy.
Yep. Awesome. Okay. Yeah, Amit, if you have any further questions, you can find us in the community Slack. I'm just going to wrap it up here because we're at about time. I'll throw in one more plug, which is something that David was talking about was we do have our docs, and at the bottom we've actually included basically like waitlist sign up form for Temporal Cloud. This is what Shannon was talking about. What I think David or Daniel. Daniel, what Daniel was talking about. It is a waitlist form, so that's why you don't get an immediate response from us. But we are looking at every single submission and keen to work with you. But even if you don't pay us to host your Temporal, we're happy to work with you to host it on your own cloud. So yeah, I think I'm going to leave it there. We have more content coming. Tiho's working on awesome videos. Dominik as well, and we have some more case studies on the way. Everyone, don't forget to check out the awesome Snapchat blog posts. Snapchat has come out as a public user of Temporal, so we're pretty happy about that. And yeah, it's just more and more examples of people adopting Temporal every day, and it's just a really exciting journey to be on, and we're glad that you're here with us. So awesome. Well, thanks very much, and I'm going to stick around to answer any other questions, but you're free to go. See you in the next office hours.